The big discrimination?
What if one of them is...
No discrimination.
No,
Physically. Not value-wise, size.
Typographically speaking. Okay. Got it. All right, yeah. Say it your way.
So, just...
You, listen.
The base to what power equals the argument.
Okay. Anyone else want to say it their way? Yes. Yeah. Trying to use some terminology. I like that. Yeah, I mean, really, the word logarithm is a little bit of an accident of history. It's a bad word for it. I mean, if you were to rename the function now, if we had that kind of purview to like change all of the world's mathematics, you might rename it like the what power function or something like that makes sense. Logarithm just like means like a calculation of some kind, right? Like, that doesn't really help us understand what it means at all. So a lot of things in mathematics are named well. This is not one of them. Okay, and also I think the worst part about it is I think that it clouds understanding is the worst part, right? It actually would be, if it were better named, people would be like, oh, logarithms are easy. But instead, some people have the impression that logarithms are like difficult or opaque in some way. But they're not too bad. And you guys demonstrated that you have some knowledge of logarithms from last year. Good job. Good job. Let me ask you one other thing. Here's one more that I thought would be good that I didn't put on here. And this one here too.
No.
Thought that one would be good as well. It's one of my favorites.
What the heck?
Well, undefined.
Yes.
Yeah, if we're working with smiley faces, these are like, these are frowny faces. Yeah, the first one, in fact, actually, so a logarithm we usually don't permit to have a base of 1. And in fact, actually for exponential functions, we don't permit exponential functions to have a base of 1. Can you imagine, like, what does 1 to the x look like? It's not really an exponential function, right? It's not really an exponential function. Same with log base 1 of x. For most x, in fact, basically every x, it doesn't make any sense. Same with this one here, like the log base negative 2 of x. Sometimes you can maybe define properly, but most of the time it's nonsense, right? So we usually require the base be some number that's positive and not 1. I don't know if you remember that requirement, but I just thought I'd throw that out there as well. So
No way!
So I was helping my brother move, and we're picking up a truck, as you do. You rent a truck that moves some stuff. This was not the truck we rented, but this was on the lot. And it was nearby the truck, and I was like, wait, hold up. Someone grabbed the couch for me. I gotta go check this out. This is amazing. So I caught it out of the corner of my eye, and I really just couldn't believe what it said. It's nearly unbelievable. Nearly. It said the unit we're doing, and there's more. There's more. If you look carefully, people in the front row can see maybe. There was like this watermarked logo behind there. Do you see what it is? What is that? It's a spaceship? No. It's a rocket, and I was like, I have to take a picture for my students at Richard Montgomery High School. They will love it. This is the name. I was just like, stars aligned. It was amazing. And I had to take a photo and show
Were
you.
you drinking your Unit 2 soda at the time?
Maybe, yeah. I know, it is really hard to believe, isn't it? It's hard to believe. All right, well, I have thrown a whole bunch of paper at you as you came in. This unit is meant to be a little bit shorter. You'll notice there's no quiz on the calendar. We'd like to get the test and the IB problem, get it here by that time scale there. We'll get it on this quarter then, we'll have a third test. That's our goal. So 3 tests on this quarter, 3 tests on this quarter. Unit 1, 2, and 3 tests on this quarter. Yeah. Is that okay? Yeah. There are no quizzes this unit, right? All right, there's something else I was going to say. Oh, yeah. So there's an assumption, listen, thanks. There's an assumption that you already know a lot of the log properties and exponential properties, so we're going to throw everything you know about logs in it, the mix in one period here, right? So you got all these properties, which we'll kind of review a little bit. And so notice that on this sheet that looks like this, that these all appear. So the only thing you'll have to take notes on per se today is just any examples that we might do, okay? So this is a nice capture sheet. I just stole it from the book. Notice, for example, this is the first thing on this sheet, yes? Okay, the definition of logarithms. Okay. That's my gift to you. So, yeah, this makes sense. This is what we mean by a logarithm. It communicates, it packages the same information, just in another rewritten format, right? So we're clear on that. And this is what we were just saying on the warm-up too, these restrictions here. B needs to be positive and not 1. And of course the argument of the log, as we've already talked about this here earlier, needs to be positive. So someone demonstrates that you can rewrite in logarithmic form this statement, which is currently in exponential form. Can you see it, Yvonne? 2.4 K.
Okay, so would be log n.
Log base m of.
Log base
It's okay.
of 32 equals 2.4k.
She's done it, you guys.
Miracle.
Okay. Well done. Yeah, and you can see why this might be useful, not just like kind of, a cosmetic rearrangement. Say you were trying to isolate k, we're one step away from having done that, right? So where this might be like, I don't know what to do, now we can see that, we could say k equals something or whatever. It's important to note too, as we do this, that the thing we have right here is the exponent from up here. So, literally, the log you get, you evaluate, what do you get as your answer? You get whatever the power was, right? The emphasis that we have in the last slide too, on the warm-up. Properties of logarithms, again, these appear verbatim on your sheet, word for word, right there, from the book, from your sheet. Okay, but let's just take some time to remind ourselves why each of these makes sense. You know from algebra 1 that b to the 0 is 1, and all you do to get this property of the logarithm, the corresponding log property, is to rewrite, just like Ivana did, rewrite this in log form. If you know this, then this is just that written in log form. Or b to the 1 equals b, something everyone from algebra 1 knows. Rewritten in log form is this property of logs, right? A similar kind of thing can be done to get these two, if you like. But I'd like to remind you of one important property of logs over here. If you have f of x equals b to the x, can you tell me what, let's say g is the inverse. What's the inverse of the function b to the x? We know what the function b to the x. B to the x is definitely 1 to 1. It definitely has an inverse. What's the function that represents the inverse of this? Yeah, log base b of x is the inverse function for that. And we know that if these indeed are inverses, then f of g of x is equal to, and also g of f. And that is in fact what these last two properties say. It's just saying if you compose a log base b with b to the whatever, then they undo each other, right? Or say you compose them the other way. You do b to the, you have b to the x, and you put this function in there. What do you get? The answer is also x, right? So that's what sometimes these last two properties are called the inverse properties, because they're just this analysis run with these two functions, right? They also kind of just make sense intuitively, right? Read this out loud to yourself. What is the power that we have to raise b to get b to the y? It's almost tautological. Like, there's no work to do. Of course you raise b to the y to get b to the y. And this last one's a little harder to say out loud, but it also should make sense at first glance too. What is the log base b of y? It's an exponent, isn't it? Because that's what logs are. They're exponents. But what is it? You know what this particular exponent lives to do? It lives to turn b into y. That's what its purpose in life is. And so what happens, do you think, if you raise b to that power? Well, of course, You're raising b to the power that, like, its sole purpose in life was it was waiting for this moment, was to turn b into y. And so guess what it does? It gives you y. So they also kind of just make sense from on a gut level too, maybe. These conventions are at play as well. This is on your sheet, and I think you've known these before. The log, the common log, base 10, we often, at least in high school, represent, if you don't see a base, we mean the log base 10, and that's what your calculator's convention is too. And then you know that a log base e, and we haven't really plumbed it up this year at least, about the significance of what e means for your life, but we will in the days to come. But know that it's a popular and useful log form, so log base. So lnx is the shorthand for that. Again, that's the convention your calculator uses as well. So that the natural log, or it's French though, it's the logarithm naturel or something. Where's Mr. Javlon when you need it?
Oh, that's why it's LA.
Yeah, the natural log, but in French. Okay. You want to practice a few?
Yes.
Ready to go. These get a little harder now. Right? Especially as you get down to I here. Look at this guy. Ooh, man, it's gonna be fun. Okay? So no
Can we
comment.
skip I?
You do as many as you can. If you need me to read one here, some of these are small. This one says the 4th root of 8 over 32. Anyone else want me to clarify one? Yeah, come on up with me. Yeah, sorry that I blurry. Which one? Yeah. My right.
I still remember this.
6 to the log base 6.
D is already here. Yeah, 5 over 2. I was like just. No.
Oh, wait, it's so cool. That's so cool. Wait, is it G? It's green. -1. Yeah. Yeah, I'm right.
Can you show me how you do
This on paper.
It'd be like 3 Yes.
Yeah.
Oh, yeah.
3 to the third. 3 to the third root of n. That's Oh wait. Wait, did you get n to no.
We haven't spoken about it. You shouldn't need any of those properties yet, but if you want to.
Well, you got 16.
Oh yeah, this is 5 cubes. Sorry.
Julie, what's the first one? What's this one? Is it 2? Kaylin, what's B? What's the answer to B? It's 1/2. Do you guys agree? Is it 1/2? No, yeah, what's the answer to C? Did you get that? 237? Do you agree? Do these people agree? Find someone who agrees with you.
Oh, wait, does that say 237 or 2 points?
It says 2.37.
Oh, so then it's just 2 points.
Do you agree? Other people? Okay. Louisa, talk to me about Z. Did you get that one? E to the 5 halves. Do you agree? Can we get an amen on that? E to the 5 over 2? E to the 5 over 2?
Wait, is that the answer for H?
Yeah? You mean ln of that? Is that what you mean?
Oh, wait, sorry, I don't know what I'm sorry. I just did
All right, let's come together. We're starting to get some tricky ones. Pranav, get E. You have that one? Negative 1/3. You agree? You do. Okay. Because we need to. I'm with you. We need to take 27 and like you take the cube root and also flip it or something. I'm with you. Okay. They're getting a little dicey. Amin, can you take F? -3, yeah, because we need to raise it to the 3rd power and flip it. Good. Now, I'll just take volunteers. What about G or H? Or take one of these ones at the bottom. You think you can take one of these at a time?
G, I think is not going to end.
Walk me through it.
Because first you break 125 into 5, and using one of the properties, you can cancel out the 5s, and then you get.
Wait, so this is 3n up here? Okay, and then you're saying the answer is 3n. Okay, I'm with you. Yeah, so you need to just do some work on the front of the problem, but then I think I'm with you on that. Anyone want to take H? Walk us through that one. Who haven't we heard from? Jaywood.
Okay, so if you use the property that's called the power rule, then you can figure out that it's equivalent to
So e to the ln 4 to the 4th is how you can rewrite that, apparently he's saying. I don't know that property, but if it were a property, you would get 256, he said, because he would cancel out. Is anyone able to do it without having to refer to some property that I don't know yet? Huh?
You do e to the parentheses around that.
Yeah, using a property from Algebra 1. Do you remember this? That this is a way you can rewrite this? Power of a power, what do you do with a power of a power? Yeah, so is this equivalent? You multiply the powers, you get this, he's saying. And then this is just 4. So we do actually, so Jaywood might be on to something, I don't know. But notice we didn't have to use his secret property, we just used the property we already used from Algebra 1. And then last, 4 to the 4th. There. 4. Yeah, so 4 times 4 times 4 times 4 is what? 4 to the 4th is.
Yeah, but why isn't it 4 times 4 instead of 4?
Well, because it says, oh, you're wondering how do we get from this to this?
Yeah.
Yeah, so this in the parentheses, do you agree, is 4? E to the ln of whatever is that whatever. Right?
No, what if
So, do you agree with the first step that we can rewrite this way?
yeah.
By Algebra 1 power rules. And then e to the ln 4, forget the 4th power out here. In the parentheses, we have 4. In the parentheses, because that's e to the ln 4. And we had a property that said a minute ago that b to the log base b of something is that something. They're inverse functions, so they cancel out.
Oh, is ln the same thing as e?
Yes, log base e is what that means. So this is e to the log base e of 4.
Okay, I get it.
All right, there's not a lot of room in here to do this. Anyone willing to do I? We'll have someone maybe do it over here on the board. Anyone willing? You got it? Yeah. Yeah, so you might be our only hope, Akshay.
17 over 8
Good job.
Yeah, I literally just figured that out.
I think it's negative.
Negative 17.
All right, she'll put up some work for this one. This is hard, though.
Okay,
Yeah.
so first you're gonna want to rewrite that because it's ugly. So you have it's 2 to the third.
Said my problem.
So it's like 8 square root, or like
Oh, wait, that's not the 2.
8 to the 1/4 over 32, which can be rewritten as 2 to the 5th. And then this can be rewritten as log of 2 to the square. So basically you're trying to figure out this, what makes this equal that. And then this can be written as 3 over 4 minus 5. And 5 is like 20 over 20 over 4. I'm sorry. So 3 over 4 is divided by 20.
What's happening in here?
Nothing.
What's happening?
Nothing.
I think there's some stuff happening. Isn't there?
No,
What's on the board?
nothing.
What's on the board? Wait, isn't this? Wait, what is that word I see?
There's nothing to see
He
here.
didn't do a handstand for us.
What?
Very mad.
What are you talking about?
And your education is less than it should be. If there are not handstands
Wait.
in the room.
Why should there be handstands in the room? That doesn't make sense to me.
What are logs?
Excellent.
How do we remember? Handstands. All right. So case closed.
I'm not sure I understand.
Case
You know what this
closed.
is? You know what this is? An academic course. This guy's we don't.
Wait, does he also not use words like negatize?
That's because negate is like a perfectly good English word.
Does he not say dipsy doodle?
No.
Oh.
You mean rewrite in logarithmic form? Is that what you mean?
Exhibit A, not a nerd. Exhibit B, the nerd.
Alright, so for the freshman room, there's this thing that happens, and Miss Get stands on her head and her hands. And
It would be good if I stood on my head. I can do that as well, but it's a little more painful.
And then we all yell something. I don't know. Let's.
Well, let's recreate. Should we? Should we recreate? Right? So right now, my calculus students, what's really funny is that in calculus, what are we doing?
We are doing logarithms.
We are doing logarithmic differentiation, right? So when I started taking off my shoes, they're like, "Where are you going?" I was like, I gotta go somewhere. They're like, if you're doing a handstand for another class and not for ours, we revolt. So I'm gonna have to go back and break their hearts. No. Sorry, there's only one place that has handstands. That's in my class, or when Mr. Chase invites me.
Yeah, when I
Which he
text
does
you.
actually invite me.
Yeah, that's right.
He says, "Can you not wear a skirt to my class?" So.
Okay.
As a result,
on with the
As a
handstand.
result, right, now again I cheat because I used to be able when I was younger to do this without the board, but now, back in the day, but now I need the board to help me out. So, when I go up as a handstand,
Oh my
we're going to say what? What are we going to say? Logs, exponents. Thank you very much.
Miss
Thank
Geiger.
you. I'll be here all the week. And now I will go tell my calculus kids, no, I'm done with my handstands.
When I first heard many years ago that this is something that was done by Miss Getz, and I was like, I'm not sure I understand what the connection is, and she's like, there's no connection. It just helps people remember it, and I guess you do. But I said we should redeem it. We should see if we can find some kind of connection that's out, like kind of mathematical. And then we said, I told her, here's how it could maybe connect. Logs and exponents have what relationship? Yeah, they're inverses, so maybe it makes sense to invert our body or something. So I was like, maybe there's some tenuous connection. All right. Oh yeah, I was gonna help you out here. All right. So can you finish your explanation before you were so rudely interrupted by Miss Getz? Listen.
This is the part I'm not really sure how to explain.
Oh, okay.
You have like 2 to the second, and currently you're calculating for 2 versus calculating for 4. So you want to like divide it by 2.
but you did get us to this place. You said that another way to write this is, another way to write the original problem is that. Do you guys agree with that?
Yes.
So let me see if I can fill in the gap on the explanation here a little bit, even though this is right. Well, can we write, the goal would be, notice that we're done with any of these problems. If we can write the argument of the logs, in this case, as 4 to some power, then it's like game over, right? It's like whatever that power is and we're done. So how can you write this, we're almost there, how can we write this instead of as a power of 2, as a power of 4? How do we write 2 as a power of 4? What is that? 4 to the what?
1/2.
So the 1/2? Alright, so there's the rewrite we need maybe. And now we can see that, oh, this is the log base 4 of 4 to the negative 17/8. Terrible, terrible, but there it is. Okay. Anyway, so I mean, that's mean, right? That's there's a lot of fraction work and things like that. So more properties, more properties of logarithms. At this time, now I realize if you didn't have algebra 2 here, these might be brand new to you. I don't know if these are in the algebra 2 algebra 2 curriculum really. But so let's just prove one of them first, just to make sure that we're clear on how to do this. And I'd like to turn your attention to the resource that looks like this. It says at the top, prove laws of logarithms. And then it has product rule, quotient rule, and power rule, and has 3 problems each. And I'll do just the product rule with you and show you how this could work. Okay? We'll prove the product rule. All right. So the first question invites you to think about what is the log of 100, this is log base 10, times, is it 1,000 or something like that? Yeah. Okay. And it said, then you are asked to fill in some boxes, so it should help me out. It's 10 to the 2 times 10 to the 3. And then it says, it invites you then to use a property from algebra 1, that we can rewrite that as 10 to the 2 plus 3. Yeah. And then by the property of logs we already talked about, what's the log base 10? Of 10 to the something? It's that something. So we get 2 plus 3 as the answer, or 5 if you will. Okay. The next one says, in that same set of problems, the log base 10 of, is it 3 times 5 or something?
Yeah.
Okay. All right. Now there's a table below to help you fill in these blanks, but they're asking you to do the same task. Do you get the flavor here? 10 to the what times 10 to the what? What is 10 to the, how do we write 3 to the power of 10? It's 10 to the what? Look at the table if you want. Apparently it's 0.477. 10 to the 0.477 gives you 3. Okay. And what about 5? 10 to the what gives you 5? 0.699? It's on the table at the bottom.
I was like, did I miss something?
No, yeah, the explanation is that everyone knows their log base 10 of all integers between 1 and 100. No. All right, so then again, applying some algebra 1, we have up top whatever 0.477 plus 0.699 is, right? I don't know what that is, but we're just applying the same logic. And so what do we get as our answer, of course? Whatever that is, right? All right, so hopefully you're seeing what's going on here. And then the last one, finally, here we go. You don't need the first 2, actually, if you understand what you're doing. Let's see if we can do number 3, which is finally going to be the proof of the product rule. Here we go. The log of A times B. Well, that's the log of 10 to the, well, I don't know, times 10 to the whatever. Well, what belongs here? What power belongs here? What is A? Written as a power of 10. It'd be 10 to the what? Use your inverse properties. Log A, right? Isn't that the power we need? Yes? 10 to the log A is A. And similarly, 10 to the log B is what we need there. And do you see how we're just going to keep making the same play? This is log of 10 to the log A plus log B. And that gives the desired result, log A plus log B. So this is the most general argument, except, I mean, add a base in all of these. I mean, you could actually generalize it more for other bases too. But in general, we have the product rule, right? So the proof then walks you through, kind of scaffolds the way in the next one to the quotient rule and then to the power rule. Try the next ones if you like, but yeah, it's the same
See on the
idea.
product right there, it says log of something to the power of r plus log of something to the power of s, right? Doesn't that mean log a plus log b equals log of ab?
Yes, that's exactly what this proves. Log A times B is equal to log A plus log B. Exactly, yes. That's what we, sorry if that got missed on us. That was the whole point of what I was talking about. My apologies. Yeah, so this is a proof that that's true, okay? I should have used R's and S's and a B. Or maybe. Okay, all right. So the other ones are similar. I'm sorry this is obscured, but it's on your paper. The change of base formula is there for the taking as well. Which I don't know if there's a proof of that on here. We could, that'll be a side project for you. You can prove the change of base formula. Okay, any other thoughts about those rules? The next thing I'm going to do is just like start having you use them here. Okay. Is this like a squatter village or something? Everyone okay here? It's like a refugee camp or something. You set up some cots or something. All right. The first one here, and I say this as if it's obvious what you're supposed to do. Some of you, the reason I wrote this question is because there was a time in our lives when your calculator didn't have a general log-based feature. I don't know. Is that still true for some of you? I don't know. But imagine you didn't have the general log-based feature on your calculator. What is that? Like Math 11 or something? Or I don't know. Is it? Matthew, it's somewhere down there. There is like a general one. You could just type this into your calculator. But without using that feature, how could you do this? Which rule? Yeah, the change of base formula will get it for you. What are you going to type into your calculator?
Log base 29. Common log 29.
Yeah, so the change of base formula allows you to do that, and then someone will tell me what that is. Does it have to be the common log? Why'd you pick that? It could be log base 10 of 29 over log base 10 of 0.2, or it could be the natural log of 29 over the natural log of 0.2. Either one, if you type those onto your calculator, should yield the right answer. Anyway, try these here while I pass out another gift to you.
Another gift.
Oh, you said these ones were high quality and quality, right?
And guess what?
I was excited for
You
that.
take the homework too. Keisha's in my class. A1 to 10.
Whoa, Mr. Chase.
Yeah, you multiply powers, right?
Oh, A1.
Oh my God.
Love these.
Look at the last problem.
Oh my.
I'm excited. I'm so excited for this.
Wait, we had test homework?
Freshmen are really confused by the
Come on, Jessica. You almost did. I saw you turn a little bit this way and then go.
Did everyone get a challenge problem set? Even like all the squatter village?
Hi, Squatter Village.
Jasmine, hook us up with the answer on this one.
Do you guys take showers with?
Wait, hold up. Before Jasmine tells us the answer on this one here, let's see if we can figure it out, right? Like just by nutting our way through it. Okay. So, if this is 0.2 is like a fifth, right? It's a fifth.
Yeah.
So this is like about 25. So what should the answer be about? Let's see, 1/5 to what power gives 25? What should that be?
Negative.
Yeah, negative 2-ish. So I'm gonna guess it's negative 2-ish. Go. Oh, you didn't have it yet?
I was trying to figure out how to do it.
Come on, JP. All right. She's gonna have it any second. Ish, like that. Is that good enough? Okay. Yeah. Is that cool? Very cool. Is it wrong? 2? All right. Whatever. What about this guy here? How do we even get started? Can someone listen up, guys? Thanks. Give us at least a direction to go on this one. Someone. Hey guys, I'll take a hand. How do we do? Let's like talk about ln, the natural log of ab cubed. How do we do that? Notice the only information given here are these two pieces of information. How do we get to a place where we can even make use of those? Ty, for instance. Plus ln b cubed. Okay, that is true by the rule we just proved on the last page. You want to take it from there, Shai?
Okay, so you can rewrite it as a equals e to the fifth.
Actually, it's well. Let's continue with this here for a second. What do we have here? Okay, and now I'd like us to think about how we can use the underlying information. It's maybe easier than what you said, though.
Yeah, I was thinking.
Go ahead, Ron.
So now we know that ln equals 5.
Yeah, this thing is the whole thing. ln a is like given to be 5. We don't even know what a is. We can figure it out maybe, but because it's given plus 3 times.
Oh, is it ln equals?
So what does that equal?
It is.
All right, so you do something similar now, please, to do this if you haven't already done it. You work it out. You can do it. Believe me. This looks like fun too. Complete the work.
Can I do the third one?
Huh? Are you coming, Keisha? Okay.
Go, Keisha.
All right. So the period's about to end in a minute or so. To get this answer up here, we might have to stop there, I think. Actually, sorry. Homework 1 and all the homeworks invite you to do some of the challenge problems. So make sure you pay attention.
Do I have to accept the invitation?
Yes.
Can I respect
For the required part of the homework. A1 through 10 is accompanying a few book problems tonight. The book problem is just not interesting or hard enough, I think.
I'm much new experience.
You will, after having done that. Was that pretty dead? Was that better person?
Yep.
Have a wonderful day, you guys.
Yes. Every day. Thank you. I don't even know mine back. Look at yours.
What did we do wrong?
No way.
Maybe you lost it in like dude, somebody stole my phone.
When? Yo, I got stolen last year too.
Hey.
That's gonna be something to celebrate, honestly.